didn't go back and look at our textbook and look at how we calculate a relative frequency. How do we calculate relative frequency?
The total number of people.
I got it wrong.
No one's answered the question. How do we calculate relative frequency?
Yeah, I forgot.
Let's go back and look at it. You have to make them add up to 100.
You don't have to make them add up to 100. Well, the relative frequency does need to add up to 1, but how do we calculate a relative frequency? Y'all are correct on the idea of frequency, but it's not just divided by 100 for kicks and giggles. It's divided by the total number. How many total people went to this family reunion? 50.
Right.
So it was supposed to be 8 divided by 50.
Oh my God.
5 divided by 50.
What figure? Oh!
We talked about this.
What figure?
Malaysia, add up all those people.
Add up all of them. Oh.
8 plus 5 is 13, plus 14 is
Okay.
27, plus 10 is 37, plus 9 is 46, plus 4 is 50. You have to find the total.
That's just raging.
Okay? And then I will say this though, there were people who put 0.08 and put 0.8 and other things like that who got better scores than 0 minus. Oh, you need a copy of this, don't you?
Yeah.
Who got better than a 0 minus. You know what they did? Any guesses?
We had tried.
No, they didn't try. They justified. I don't care if you put an answer and it's right or wrong, because that doesn't tell me a whole lot. If you even just put the answers for the relative frequency and then the graph and you didn't justify anything, it's only a 1 plus on that scoring rubric. You got to keep that in mind. But you can justify, get it wrong, and get a higher score than that. So this is what I did for parts A and B. Any guesses what score I would have given myself on this? And I did this partially because I want y'all to learn. If you look at the scoring rubric, how much detail is there? Not much. The only detail I give is that there's that 50 total right there. That's a 3D at most. Right? Meaning that there's lots of details missing. Is it correct? Is it slightly justified? Yes. It might even only be a 2D because I don't give much. You need to tell me more than just this. Okay? You do. But those are the relative frequencies. And I'll say this. I would just make a note to fix your graph. I wouldn't do all the write down all the relative frequencies because we don't have time for that. But you can write down this equation so you know to study that for the future. For part C, a lot of y'all made this one way more complicated than you had to. What does it mean for a histogram to have a normal distribution?
It's roughly symmetrical.
Okay, it's non-symmetrical.
Roughly symmetrical.
It's roughly symmetrical. It's not skewed. What else? It doesn't have to be a perfect curve, but it needs to be, what's the shape also called? Starts with a V, but it's not bimodal, that's for sure. Bell-shaped?
True.
I'm going to say it's not bimodal. Does it need to be bell-shaped?
Yeah.
Look right here. Is this roughly symmetric? No. Not with that drop right there, it's not. For sure. Also, do you see how the peak is right here at the third bar? And then it has a tail off to the right-hand side? This is slightly skewed right. That's not bell-shaped. That's not normal.
So what would you write?
I'm about to show you. Before I show you, analyze the data displayed. What are the 4 things you should have talked about? Cuss, center, unusual aspect, shape, spread. The histogram is not approximately normal. The data is not bell-shaped or even really roughly symmetric. That's not a 4 plus, that'd probably be a 4. Missing the detail of that it's slightly skewed right. Okay? But notice how, and this is what I feel like a lot of students miss in the justification, I went back to the definition of what it means to be normally distributed. If it's a normal distribution, it needs to be roughly symmetric, it needs to be bell-shaped, and I addressed the fact that it's not. I gave a claim, it's not approximately normal, and I gave my justification for it. That's what I'm looking for. Go back to what does this concept mean? If you know what the concept means, then you can answer it because you have clear evidence. Notice a typical, right? The idea of center is a typical. There's no way to find the average or even really the median, but a typical age of people attending a reunion appears to be 30 to 45 years old. That's the peak, right? It's kind of in the center of the graph. There don't appear to be any gaps or outliers in the data. Notice how I keep saying don't appear. I don't have clear evidence for it, but I believe it to be true based on what I see. There's my unusual aspects. The data appears to have a standard deviation of about 15 years. Note, I treated 45 as the center and estimated 3 standard deviations around, so 15 each direction. So that's how I estimated that standard deviation. Okay? You could have just talked about that. You could have talked about the range. I think some people refer to between 0 and 90 years old was the whole thing, which would be a range of 90. The age of people at the reunion is almost symmetric, but it is really slightly skewed right since the tail is slightly longer on that side. By the way, these slides will be up on Schoology, so that if you want to go back and look at my notes on this more, you can. But that's CUS, the center, the unusual aspects, the shape, the spread. If I ask you to analyze the data, you should note CUS. Now, one of the other things you got to remember is, and I didn't do it for every part, but I did it for 2 different parts, you need to include the context, which some of you all have a note there that says CUS in context. Okay? I would make that note to myself. That's too much to write right here. But you can make the note CUS in context. What are your questions before we go to number 2? Huh? Okay. Alright, so number 2. The mean battery life of one model of tablet computer is 7 hours with a standard deviation of 0.7 hours. Assume the battery life is normally distributed. Determine the percent of tablet computers with a battery life between 1 standard deviation below the mean and 1 standard deviation above the mean. Shouldn't even have to, bless you, shouldn't have to think about that one. What should we know automatically?
It's like 68.
It's 68% based on the what?
The empirical.
The empirical rule, right? You need to reference that empirical rule in justification. What, Madison?
Now we're gonna ask you about that.
That if you need to reference it, y'all, I'm about to take that away from you if we can't focus.
Oh,
Madison.
what?
But don't get upset because I already answered your question. I was planning on answering it. So just wait till I talk, and then if I don't answer it, ask the question then. What do you think I was looking for as a part of the justification for Part A? What was I looking for as part of the justification for Part A?
Oh.
Not chart, the graph, right? Could you have drawn a graph with the standard deviations in there and shown that with shading, things like that? Right here, determine the percent of tablet computers with a battery life between 5.6 and 9.1 hours. Could you still use the empirical rule there?
No. Wait.
You check, 7 minus 0.7 twice gives you that 5.6. 7 plus 0.7 3 times gives you the 9.1. So it's 2 standard deviations below, 3 standard deviations above. Notice how I reference the empirical rule. Approximately 68% of data within 1 standard deviation of the mean in normal distributions. And so I showed my 6.3, my 7, my 7.2, noting those standard deviations there. Notice how I have all this work right here showing how I got different parts. I noted, hey, I have between -2 and 0, so half of 95% is 47.5. Because I went from the mean up to 3 standard deviations, I did half of 99.7, which gives me a total of 97.35%. And notice how I added context in here, right? This was just 1 standard deviation below and above. This was more about the hours, so I included context. This part B here would have scored higher than part A. This would be a 4 plus, it has the context. This would just be a 4, because of no context. Okay? What are your questions about number 2 at this point? Madison?
Alright, I got a 3D thingy, I think it's a T.
Plus, 3D plus.
Yeah. On B, and I said the percent of computer tablets with a battery life between 5.6 hours and 9.1 hours is 97.35. And you kind of said like the same thing. So I'm confused.
So did you give me the same level of evidence that I did over here?
Oh, I didn't draw nothing out. I didn't know I had to.
Oh. Completely justify your responses. And you should never say I didn't know I had to. You have a purple sheet that I would get out every single time you have an understanding check, every time you have a test, and it very clearly says, every time justify. Even if it's multiple choice, what do you gotta do? Justify. Everything. The level, and y'all gotta remember guys, it's not me just grading, it's me giving you feedback and me scoring. How much evidence are you giving me of your understanding? Does this provide more evidence of understanding with that graph in there and the z-scores marked?
Yep.
Yes. Okay? So we just gotta learn that we have to show our evidence to score higher. Okay? Number 3, hopefully we're better with z-scores than we were. So here's what I did with this. Notice I literally tell you to calculate the z-score. A whole bunch of y'all went to percentiles. This wasn't asking for a percentile. We're looking for a z-score. Value minus mean divided by standard deviation. I use my things up here to help me substitute in, because AVA is 53. That's the value. The average is 50, and I divide by 2.5. Notice I didn't go much beyond this, but I marked my mean. I did 1 standard deviation above and a second standard deviation above. Why do you think I didn't do anything else there? I didn't need to. I was only looking at someone who was 53 and the percent who are shorter, right? So I only went to there because that's my z-score of 1.2, between 52.5 and 55. Okay? So I calculated the z-score. I could have probably given more evidence here. That would probably not be a 4+. Looking at that, probably a 3D+, right? I noted this as the mean and this is the sigma, so that would probably be a 4. Identifying those different things and substituting them in. Okay? Identifying this as the value would have added on. Part B, don't forget, what is a z-score? It's the number of standard deviations either above or below. When would it be below the mean? When what's negative? Not the standard deviation, remember, that's my standard deviation. You actually can never have a negative standard deviation. When what is negative?
The z-score.
The z-score. And this is why I need y'all to understand, it's not me being nitpicky, it's asking you to show greater evidence. If you say when it, you could be meaning standard deviation, but that's definitely not standard deviation, it's the z-score is below. And so we have to be careful with our language. These things mean something. Earlier, not to pick on it, but group 1 was wrote z equals like 0.158. But that's not a z-score, that's a probability. Very different things. The z-score gets us to the probability. We need to be careful about that. I will point out, and I wouldn't expect you necessarily to, we've already calculated the z-score for 53, right? And so I did the z-score for 46, and I showed what I put into the calculator. But does anyone know what D is definitely missing that would prevent it from showing high levels of understanding? Yeah, I didn't draw it out. Just like Madison, you didn't draw it out earlier. This would only be a 3D+. Now remember, a 3D+, that's one of the highest scores you can get. If you look at the rubric, right, a 3 shows clear evidence of understanding, and the plus is the higher section of it. That rubric matters. When you get things back, look at the rubric. Okay? Any questions about number 3 before we continue?
No, sir.
Good, good. Tori, you raise your eyebrows like, no, I'm not good, but I don't want to ask a question.
I'm okay. I'm gonna look at the video.
Okay. Please note, right, I explain it here, z equals 1.2 from the table, right? I talk about how that's the area under the curve, so 88.49% of girls are shorter than AVA. Notice how I added in context here? I added in context here. That is stronger evidence of understanding, including that context of what these numbers mean. And the only thing that was not covered on this understanding check is the idea of probability. right? If you look at your in percentiles, okay? If you look at your 2 understanding checks, it covers everything that could show up on the test, but I would look through all of the notes in your textbook as well. The only things that weren't covered were probability and percentiles. That's it. I think for the most part we're pretty good here. So talk the talk, I pass this back out if you have this. No, it's hard to learn when your head's down. Come on, head up. So, really quickly, notice these are more just predictions. The if you're looking at 17 hours, is that z-score going to be positive or negative? Why? Yeah, well not the z-score, the value, right? Notice the mean is 16. That value of 17 is above the mean. So, 17 hours, the z-score is positive. Because again, the value is above the mean. Okay? Is the z-score associated with 15 hours positive or negative? It's negative because that value is below the mean. That's the whole point, is that whether the z-score be positive or negative is whether the value, which the value corresponds to the original normal distribution, whether it's above or below the mean. Okay? What are your questions about 1 and 2 there? Okay. Do we need to go over how to calculate the z-scores? We're good there? Okay. We're going to need the z-score for number 4, so the z-score would be the value 17 minus the mean of 16 divided by the standard deviation of 2.5. That gives me a z-score of 0.4. Now you can use a table or you can use a calculator. All right, so there's my mean of 16, which is a z-score of 0. Right, there's a standard, 1 standard deviation, so 18.5 with a z-score of 1, and we're looking at 0.4. Right? And for question 4, which direction do we want to go? To the left. We want what is less than, right? Or correct? So what's the lower bound? Negative infinity. It keeps going for forever. It doesn't really have the lower bound, so I put negative 100 in the calculator. What's the upper bound? 0.4. Now, so remember that 17 was the original value. We based it on the z-score at this point. But also, I will point this out. Anytime I'm looking for area to the left, isn't the table literally designed for that?
Yes.
So this would be a good time to use the table. Because I'm looking for the area to the left of z of 0.4. So what was the area to the left? Somebody should have the answer somewhere. What is it? So the area is 0.6554?
Yes.
And so that means that what percent of laptops?
65.54%.
So 65.54% of laptops have a battery life that is less than 17 hours. That's what that's saying. But if I look at number 5, what is number 5 asking for?
It's asking for which one will last more than 17 hours.
Okay, so that's the 17 here, which is a z of 0.4 or more. You don't have to put that into the calculator again. What can you do?
You can do 1 minus 0.6.
If you've forgotten this, don't. What is the total area underneath the standard normal curve? 1. So if we have this to the left, what's to the right is 1 minus that. Which leaves me with 0.3446 or 34.46% of those laptops have a battery life more than 17 hours. Does that add clarity for those of us who struggled with that information?
We did this as a group, didn't we?
Yeah.
I thought I was smart, man.
Well,
I'm surprised
what'd
I
you
even
score?
did that.
The highest score is a 4.
But I thought we did it alone.
Yes, we went over it during the tutoring session last night.
Yeah, but you're right.
Okay, moving a little bit more quickly, we only have a few minutes here. So this is the first homework. Now I'm going to go ahead and tell you, I cannot put the teacher's notes from the textbook online, or I can't put it in Schoology. But here are the relative frequencies. A whole lot of us said 0.07, 0.28, so on. But what we need to recognize here is, what was the total number of runners? How many total runners? 200 runners. Okay, this is lesson 1. It's page... Page 40, no, that can't be M549, I don't know what it is, sorry. M517, thank you, okay. So M517, so this goes back to what the understanding check we were talking about, that relative frequency is 7 out of 200. And then 28 divided by 200. And I will point this out because I did see this mistake and I need y'all to pay attention. When you do the histogram, 2 things. You need an even scale on the y-axis in 5-17. It's a homework assignment that I gave back. Okay? But I need y'all to pay attention. Don't even get it out. We got 3 minutes. I need eyes up here. Don't get it out. I'm about to talk about the 2 number 1 or the major issues I saw. When you put a y-axis, you cannot do this. Anybody know what I'm doing wrong right now?
No, 0. Oh wait, you going out of order. Oh wait, no.
It's not that I'm not going in order. I want you to notice, you see this distance right here?
No, 0.
Right now I'm saying that that distance is 0.1, right? This same distance though, isn't that half of it? That doesn't match up. You have to go by an even scale. If you go by 0.1, you have to go by 0.1 again. I would do 0.05, 0.10. Some of y'all are getting thrown off by that. Go to the hundreds place if you need to. That is acceptable. Go by 500ths every time. When you look at your bars on the x-axis, I saw a lot of people doing this. Well, first off, be careful, right? I saw some people jacking this up because they didn't notice the 0 in front. That is not the same as 0.355. But when you do your bars, 1, they need to touch. 2, I saw people doing 14 to 18. But if that's 14 to 18, isn't the lowest part here 14? And the highest part of the bar is 18. The next bar starts at 18 and goes to 22. The next bar, which I'm just going to go, goes from 22 up to 26. Go and look at the notes from the beginning of that lesson. Be careful about those bars, but also notice, label your axes. Draw that out. Okay? Please note, we've addressed this multiple times now. Why does population B have a higher mean? Because it's further to the right. Left versus right is the idea of mean. The height and the width matter for the standard deviation, the spread. Height and width go with spread. Notice how much context the book has for all of that. Consider your context. Sorry, I'm having to go through this. For the most part, we're good here. Make sure, though, you pay attention to whether you can use empirical rule or you have to use z-scores. Tonight? No. I planned on going over this homework, but I don't have time to do that, sorry. I have to move through the first half quicker in first block, or third block. Your assignment, study for your test. The last thing I want to leave on is this. Don't forget, while you have learned, and hopefully you've learned a lot today, you are still what?
Capable.
But not just capable. Capable of
Learning.
Amazing.
more.
Oh.
When I ask this, I'm going to put this in every slide from here on out. When I ask you are still what, the response is not just you're capable. You are always capable of more. Okay? So don't forget, while you've learned and maybe even learned a lot today, you are still what?
Capable of more.
Oh man, I didn't have everybody get involved in that. Madison, I need you focus, Colin, everybody. So don't forget, while you have learned and maybe even learned a lot today, you are still what?
Capable of more.
Go home, watch the videos, come into tutoring tomorrow morning. You are capable of great things. Don't sell yourself short. Yes, sir. Don't forget, you do better on that test, the understanding check. The understanding check grade gets replaced. Improve over your test or your understanding check grade.
In my history fire.
You not here? Yep, I think so. So can I take a picture of the did you just not interpret this? Well, this was sorry. Why did you say it so many times in a row?
That's only twice.
Hey, Kaya, in a row. Is this yours? Do you know whose this is?
This is mine.
Oh, just